All right, finding complicated integrals, it's kind of like the chain rule, but just backwards. The only difficult part is that it has to match a very specific form. The derivative of what you're making a substitution for has to be present inside the integral, at least up to a constant. Let's see. So if we want to integrate this function, 3x plus 4, and then to the fourth, if we don't have the substitution rule, then we would have to write out 3x plus 4 times 3x plus 4, right? 4 different times, and then that's a lot of multiplication. I don't want to go through that. So what I'm going to do is create a new variable. Let's call it w. And I'm going to let w be 3x plus 4. Right, because then this becomes easy. This would be the integral of w to the 4. All right, now if w is equal to 3x plus 4, I can differentiate w with respect to x. So what's the derivative of 3x plus 4 with respect to x? That's a 3. So I can solve that for the dx by throwing the dx onto the other side and dividing by the 3. So dx is equal to 1/3 dw. So I can rewrite this integral as integral of w to the 4. And then I can replace that dx with 1/3 dw. This is an easily solvable integral, right? That 1/3 is a constant. It can be pulled out of the integral. What's the integral of w to the 4 with respect to w? That's just your power rule. Right, this will be 1/5 w to the 5th, and plus c because I don't have limits on my integration. This is the indefinite integral. Okay, so our integral right now, we have it written as 1/15 w to the 5th plus c, but w was something that we gave ourselves, so it shouldn't appear in our answer. Let's take it back to x. This will be 1/15 w to the 5th plus c, and w was 3x plus 4. So you can see if you took that and you differentiated it, the 5 would come down, hit the, in fact, let's go through this. If we differentiated 1/15 3x plus 4 to the 5th plus c, the 5 comes down, hits the 15, becomes a 1/3 to the 4th. And then by the chain rule, I need to multiply by the derivative of 3x plus 4. That's the 3. Our 3's cancel. We're left with just 3x plus 4 to the 4, which is what we wanted.